On numbers 3 and 4, you're asked to factor the trinomials. So you should know these are called trinomials because there's 3 terms in each of these expressions. So when you're asked to factor them, typically if you factor a trinomial, you're going to be getting it into the form where you have a binomial times a binomial. So 2 terms in one parentheses times 2 terms in the other parentheses. The very first thing you always want to do is look to see, is there a GCF in that expression that you can factor out first. So you're looking at the number part to see if there's a common number in that they all have that you can factor out. So when I look at the numbers, the coefficient of this term is 1. So obviously there's not going to be a GCF because the only number that's a factor of 1 is 1. So factoring out a 1 is not going to be helpful. So this one does not have a GCF. When I look over here at my numbers, I have a 12, a 22, and a 20. Well, the first thing I notice is they're all even, so I know they at least have a 2 in common as a common factor. Is it the greatest one? Well, look at the other factors of 12. The next factor is a 3. Well, these numbers are not divisible by 3. We have 4 that we could check. This is a factor of 4, but this one does not have a factor of 4. We have 6 we can consider, which neither one of those will work. And 12, of course, is not a factor of all 3. So the largest number that's a factor of all 3 of these numbers is a 2. So you're going to begin number 4 by factoring out a 2. That means your GCF goes outside the parentheses and you put what's left over in the terms after you've factored out that 2, which means you're dividing each one of those terms by 2. So 12 divided by 2 is 6, so that leading term now is 6x squared. 22 divided by 2 is 11, so that middle term is 11x. And 20 divided by 2 is 10, so now we have minus 10. So don't forget those signs are really important there. They didn't change when we factored out the 2. Okay, the next thing you do depends on whether the leading coefficient is 1 or not. So standard form of a trinomial, we write it as ax squared plus bx plus c. So the leading coefficient is what we call the a value. So if your a is 1, then these are the easiest types of trinomials there are to factor. Because if your a is 1, you only need to find factors of your c value that combine to get your b value. So on number 3, our a value is 1. The leading coefficient is a 1. So that's all we need to do. We need to find factors of c. C's the constant. So we want factors of 30. So I can list the factors of 30. 1 times what? 1 times 30. 2 times what? 2 times 15. 3 times what? 3 times 10. 4 is not a factor of 30. There's nothing I can multiply 4 by and get 30. 5 times 6 is 30. Well, then when I get to 6, I start repeating the ones I already have. So those are all the factors of 30 that we need to consider. Now, don't forget, since this is a positive 30, we also could have 2 negatives as our factors, because a negative times a negative is also a positive. So we would also have to consider the fact that negative 1 and negative 30, negative 2 and negative 15, negative 3 and negative 10, and negative 5 and negative 6 would be factor pairs to consider as well. Okay, so we have all our factors of our constant. We want the pair that combines to get our b value. B is the coefficient of your x term. So for number 3, our b value is 11. So we're going to be looking for which one of these factor pairs combines to get a positive 11. Well, the pair we're looking for is this positive 5 and positive 6. We don't want the negative 5 and negative 6 because they combine to get negative 11. So positive 5 and positive 6 are how I'm going to write my factor pairs. Now remember, it's a binomial times a binomial. The second term in each one of these binomials is going to be multiplied together to get an x squared. So the leading term of each one of these binomial factor pairs are going to be an x. X times x is x squared. The 5 and the 6 are the second term in each one of these binomials. And since they're positive, I'm going to put plus 5 and plus 6. Now, if you put as your answer x plus 6 times x plus 5, that's fine too, because multiplication is commutative. The order doesn't matter, so it doesn't matter which one of those binomial pairs goes first. Now, you can check to make sure you're correct by distributing. This is multiplication, so you're going to distribute. This term has to be multiplied by both of these terms, and this term has to be multiplied by both of these terms. So when I multiply x times x, I get x to the second power because I add those exponents. X times 5 is a positive 5x. And then I multiply 6 times both terms. 6 times x is a positive 6x, and 6 times 5 is positive 30. I can combine these two terms because they're like terms. They're both just an x. So if I have 5 x's and I add 6 more x's, I have 11 x's altogether. So this is just my check, just to make sure, did I get what I started with? This is my factored answer, x plus 5 times x plus 6. Now, of course, not all of them have an a value of 1. Like when we factored out the GCF here, we still have an a value that is not 1. So when a does not equal 1, that's when you use what we call the bottoms-up method. Okay, so let's go through the steps for bottoms up. The very first thing you're going to do is, now we're factoring this trinomial, not this one anymore. We factored out the GCF. So I know my answer, this is really, really important. I know my answer has to have that GCF as part of it. So I go ahead and I just write down a couple steps there, and I put that GCF, and I go ahead and put my parentheses for my binomials, and that just helps me remember that I can't forget that as part of my answer. I'm going to lose points if I do. So this is the trinomial we're factoring now with the bottoms up. So the first thing you're going to do is you're going to multiply your a times your c. So remember, your a is your coefficient of your squared term. So our a value is 6. B is the number in front of x, so our b is 11. And c is your constant, so our c is a negative 10. That sign goes with that number. So when I multiply a times c, I have 6 times negative 10, which is a negative 60. So I want to find factors of that term. So factors of that a times c value that combine to get your b value. So very similar to up here, except we just found the factors of c. We didn't have to multiply a times c. Well, the reason why we didn't have to multiply a times c is because a was 1. So 1 times 30 is still just 30. But in this case, we have to multiply a times c. So in our case, we want factors of negative 60. Well, the number we want factors of is negative. So it's going to be a little different than what we did for positive 30 over here. Because with positive 30, both of our factors were either both positive or both negative. But if you're multiplying to get a negative number, your signs have to be opposites, one positive and one negative. So when we consider 1 times what, it's 1 times negative 60. But we could also have a negative 1 and a positive 60. So your signs have to be opposite if they're multiplying to get a negative. So there's 2 factor pairs right there. And then we would go to 2. 2 times negative 30 or negative 2 times positive 30. 3. 3 times negative 20 or negative 3 times positive 20. Now, you may be saying, how am I supposed to know all the factors of 60? Well, hopefully you do know your multiplication facts good enough to be able to do that. But if you don't, I'll show you a little, a little trick to find them on your calculator. So on your graphing calculator, you can go to your y equals. Let me clear out what I've got in there already. And I'm going to put in the number I want the factors of, which in this case is negative 60. And I'm going to divide by x. So always the number you're trying to find factors of divided by x. Now I'm going to look at the table, which is in blue above graph. So I'm going to hit second graph. And it's going to give me my factor pairs. You see 1 and negative 60, 2 and negative 30, 3 and negative 20. You see how it's giving me those? For the other ones, the negative 1 times 60, I'd have to go to the other side of 0. But if you get these factors, all you'd have to do is change the signs to get your others. So here's some more factor pairs we need. We have 4 and negative 15, or I could write negative 4 and positive 15. Here's another one, 5 and negative 12, or negative 5 and positive 12. Let's keep going here. We have another one, 6. 6 and negative 10, or negative 6 and positive 10. And then when we get to 7, we get a decimal. So of course we're not going to write that as a factor pair. We're looking for integers. So all of these are decimals until I get to 10. I already have that one. I already have 10 and negative 6. So now that I'm starting to repeat, I don't need to keep going down the list. Those are ones I already have. Okay? So I'm looking for the factors of AC. I've got all those that combine to get B. Well, what's my B value? It's 11. So I'm looking for which one of these factor pairs adds to get a positive 11. So when I look down here, here is the factor pair I want. I don't want 4 and negative 15 because that's a negative 11. I want negative 4 and 15. Negative 4 plus 15 is 11. So I'm going to begin by writing this as factor pairs like I did the x plus 5 and the x plus 6, but I'm going to be using a negative 4, so I'm going to write x minus 4, and a positive 15, so I'm going to write x plus 15. Now, obviously I'm not finished. If I multiplied these two binomials together, I would not get 6x squared plus 11x minus 10. X times x is not 6x squared. So that's just a part of the process. So the next thing you have to do, since remember we multiplied a times c, I've got to undo that multiplication. And what undoes multiplication? Division. I've got to divide by a now. Remember, we didn't have to multiply a times c up here because a was 1. So we were done when we did this. But now we've got to divide by a. We've got to undo that multiplication. So I'm going to divide both of these terms, just the number part, by my a value, which in this case is 6, not the 12. We're not factoring this, remember. We're factoring this trinomial. So I'm going to divide by 6. Now the next step is one that a lot of people forget and miss the answer because of that. You must simplify those fractions. If they will simplify, you must simplify them. Well, 4 6 will simplify. If you don't know what it simplifies to, you can use your calculator. You can put in your calculator 4 divided by 6. You're going to get a decimal answer. Let me get that where you can see it. But when you get the decimal answer, you can get it back to a fraction by hitting the math button and then hitting enter 2 times. Enter, enter. And it'll give you that as a fraction. There's kind of a glare there. Okay? So 4 6 simplifies to 2/3. So I'm going to rewrite this binomial as x minus 2/3. I'm going to do the same thing over here, 15/6. So I can put 15 divided by 6. And when I get the decimal, just hit math and enter 2 times. And it tells me it's 5/2. So I would write that as x plus 5/2. So don't lose those signs. That's really important. So now we're ready to do the bottoms up method. The reason why it gets its name is bottoms up. So at this step, you move the bottoms up. Now that's not very good math terminology. What is the bottom of a fraction called? It's called a denominator. So these numbers that are in the denominator are the ones that move up. And what do we mean by that? Well, moving them up means put them in front of the x. So that's where they move to. So now I'm ready to write my answer. Remember I skipped some steps and I put the 2 there? That's because that 2 is part of my answer. Don't lose that GCF. So now we have 2 times 3 goes in front of x, so that's 3x. Don't forget that sign goes with that 2, so minus 2. 2 goes in front of x, so 2x. That addition goes with that 5, so plus 5. So this, including the 2 of the GCF, is my final factored answer. Whoops, just a second. My lights go off. So, all right, so now we can check it. Just like we did up here by distributing, I can check this. So if I multiply the 3x times the 2x, 3 times 2 is 6. X times x is x squared. If I multiply the 3x times the 5, 3 times 5 is 15, and then the x doesn't have another x to add exponents with. Then I multiply the negative 2 times the 2x. Negative 2 times 2 is negative 4, and we just have an x. And then negative 2 times 5 is negative 10. I can combine my like terms, the ones that have an x, 15 and negative 4 is a positive 11. So I have x squared, 6x squared, plus 11x minus 10. Now that's not what I started off with, but remember this GCF has to be multiplied by all of those terms as well. So now when I distribute that 2 times all terms, I get 12x squared. 2 times 11 is 22, plus 22x. 2 times negative 10 is negative 20. And that is what I began with as my problem. So I know my factored answer is correct.